Thank you, Vivek, sir. So, first of all, extremely sorry for delaying the session today. As I think, there was one event was going on in our college, and we just got free. So I just started the meeting. So today is the last day of this FDP, right? And I'm going to talk about the one-way ANOVA. So give me a second as a notion of the So means as a convention, usually I discuss firstly the conceptual aspect of a particular topic, and then we are moving towards to the SPSS for doing the hands-on for the one-way ANOVA that I will do today, right? So before proceeding to one-way ANOVA, can anyone tell me what is independent sample t-test? Yes. Am I audible? Anyone? Good evening, everyone. I'm audible. No
Yes,
responses. Yes. So, can anyone tell me what do you mean by independent samples t-test? What is the purpose? What is the variable requirement?
ma'am, it is a test that derives the significance difference between means of two unrelated groups.
Okay, fine. So, how many variables we need to have for performing independent samples t-test?
Ma'am, it's two means, so one variable will also do, mean will also do, one independent.
Sorry, ma'am, will you please repeat?
Ma'am, it's two means from unrelated groups, so one variable should also do one independent variable.
One independent variable we need to have to perform independent sample t-test. Is it what you are saying?
Yes, ma'am. Yes, ma'am. As far as I can remember, I'll try to revise again and just.
Okay, no problem. I think I am facing some problem. Yeah, I think it is okay. Just okay, fine. So no issues. Thank you so much. I think it was Ritika ma'am, right? Ritika ma'am?
Yes, ma'am.
Yeah, no issues. So friends, I'll talk about firstly about the independent sample status, then we will move for the one-way ANOVA. So in the previous session, I discussed about the independent sample status, and Ritika ma'am rightly said that generally we need to have independent samples or unrelated groups to perform independent sample status. And if I talk about the basic variable requirement for the independent sample status, so we need to have two variables. The first variable should be the independent variable, that is the categorical, and we need to have two categories in that. Second variable is the continuous scale variable, and we can treat this variable as a dependent variable, right? So this is the main crux about the independent sample status. Question comes why I have talked about here the independent sample status. So as we proceed with the presentation, you will get the answer that why I asked you firstly about the independent sample status, right? So independent sample t-test, one-way ANOVA is also the parametric test, right? Which is generally considering the normality of the data, and using a one-way ANOVA, we can say this thing. We need to use generally parameters of the population. If I am talking about who has given this one-way ANOVA, so you can read. It was given by Sir Ronald Fisher. He was the British statistician. So I think after his name, if you people have performed ANOVA previously, you know we are getting the F statistic. So generally F statistics, we are giving F in, we are taking the term F or the alphabet F in the honor of Sir Ronald Fisher. So Purpose of one-way ANOVA is also to find the significant mean difference, but in more than two groups. So I think now you can relate this thing. I said that when we talk about independent sample t-test, there what we need to do, we need to have one independent variable with two labels or two categories. But when we talk about one-way ANOVA, here also we need to have one independent variable, but in that there can be more than two groups. So the meaning is that there is a limitation of independent sample t-test, that it can only compare the two groups or two samples. What if when we are having more than two groups or samples? So in that case, that is not the capacity or capability of the independent sample t-test to compare more than two groups. For the purpose, we are having one-way ANOVA, right? Is it clear to everyone?
Yes, ma'am.
Yeah. So here you can see I tried to put one example. Suppose I'm talking about the impact of teaching techniques on the performance of the students. So if suppose I want to perform one-way ANOVA, I need to take at least three categories in the teaching technique. These can be audio, video, discussion, or any other method which you are using to teach your students, right? So that way you can compare the mean difference in the performance using these three different teaching techniques, right? Now we have already seen the regression analysis. I think on Saturday we discussed this regression analysis, right? So there, what we have seen that in the output of regression, we are also getting the table of ANOVA. So that way you can say this thing that ANOVA is a precursor of the regression, and usually for the general linear modeling, we are using ANOVA. And ANOVA there helps us to signify this thing whether the relationship is linear or not between the variables. So that way we can say that this is one more use of the ANOVA. That ANOVA we can see in the regression also. Further, talking about generally, you can see that one-way ANOVA can commonly used to test the following things. Generally, you can compare the significant differences among the means of two or more groups. Then you can compare the significance differences for the mean between two or more interventions or two or more change scores. In this three different situations, one-way ANOVA can be used. Talking about the variables requirement, as I said, in case of one-way ANOVA also, we need to have two variables, dependent variable and independent variable. Dependent variable nature should be continuous in nature, but independent variable nature should be categorical in nature, and it should have more than two groups, right? And when we talk about SPSS, generally in SPSS, the independent variable is treated as a grouping variable or the factor variable, right? Is it clear to everyone? May I proceed from this
Yes,
slide?
ma'am. Yes,
Yeah.
ma'am.
Yeah, thank you. So, talking about the nature of the dependent variable, it should be continuous variable. Independent variable should be categorical with at least three labels or groups or categories or samples, right? Example I have already given. If we want to compare the performance of the students, so that means we want to we are considering the marks of the students as their performance, and we are comparing the marks on the basis of from which techniques the students were taught, right? So here you can see dependent variable will be the marks, independent variable will be the method, and in that we are having three categories. So minimum three categories we need to have in the independent variable to perform one-way ANOVA. Further, talking about the assumptions of one-way ANOVA, so I think you people are now used to of this, that generally in case of each and every statistical test, we are having the assumptions. So here in case of one-way ANOVA also, we are having the assumptions, and these assumptions are, the first one says, assumption of independence. That means two or more independent groups that represent independent variables should be categorical. So I think it is clear to everyone that we need to have one independent variable, and that variable should be categorical in nature, and it should have minimum two groups. But if we are looking for the one-way ANOVA, so it is like we need to have more than two groups. Second assumption says we need to have the normality of the dependent variable. We need to check whether the dependent variable, which is on continuous scale, it should be approximately normally distributed. Next one is assumption of homogeneity of variance. So I think you can recall the independent samples t-test. There we have seen that generally in case of independent samples t-test also, we need to see equal variance for the variable, that is dependent variable, in the two groups of independent variable. But here when we talk about homogeneity of variance, here we can say that the homogeneity of variance, we are looking for the dependent variable according to the categories of the independent variable. That means in all the categories of independent variable, the dependent variable variance should be same, right? Last one is there should be no significant outliers in your dependent variable. So I hope it is clear. All the assumptions are okay.
Yes, ma'am.
Yeah. So usually the question comes, if assumptions are not followed by our data, what we need to do? So the answer is you need to go for the non-parametric test. And in case of one-way ANOVA, the suitable non-parametric test is the critical valence test. Talking about, I think you people will be acquainted with this particular graph. This graph is for the homogeneity of variances, right? So there you can see, so this graph is for the normality of the variable. So there you can see this is the histogram, and using the histogram, we are generally ascertaining the normality of the variable, right? So if suppose not exact normality you're getting looking using the histogram, still you can say this type of distribution of data you are getting through the histogram. You can ascertain this thing that your variable is approximately normally distributed. Then talking about the Levens test, I hope you can recall this we have already seen in case of the independent sample t-test, where we have seen the null hypothesis says that variance is equal. So you can see all the variances of whatever number of groups we are having. So here I have taken the hypothesis in context to only 3 groups. So in all the 3 groups, we are considering that the dependent variable variance is similar. This is the null hypothesis. Alternatively, we are saying this thing that the variance is not equal, right? So that way, this is the Levens test. We will check in the ANOVA also. Further, the formulation of the hypothesis in case of one-way ANOVA. So if we want to make our hypothesis symbolically, so we can make H naught as mu1 equals to mu2 equals to mu3 up to mu k. That means whatever number of groups we are having, in that we need to compare the mean of the dependent variable. So we can say this thing that in all the mean is equal, right? This is our null hypothesis. Or in the text form, you can say there is no significant difference in the mean value of the dependent variable across all the categories of independent variables. This is the meaning of the hypothesis in the text form. And alternatively, you can see what is written here. This alternate hypothesis says at least one mu I is different. That means at least one population mean is not equal to. So this indicates that there is a problem with the ANOVA. What is the problem? Because this only says that one of the mu I, that is the population mean, is different. Meaning is that suppose your what I say, suppose your alternative hypothesis is accepted. Alternative hypothesis will accepted, meaning is what? This says there is a significant difference, right? So we are comparing the various groups. So that means ANOVA will not tell you in which groups that difference is existing, whether in the group number 1 and 2, or 2 and 3, or 3 and 1, or in all the 3 groups. This we cannot ascertain using the one-way ANOVA. So this is the kind of limitation of the one-way ANOVA, that it says in at least one of the group the difference is existing, but in which group that group difference is existing, or in more than one group also it is possible that the difference is existing. So that we cannot ascertain using the one-way ANOVA. For that, we need to further go for the multiple comparisons, that is post-hoc test. I hope I'm clear on the slide. Right? May I proceed?
Yes, ma'am.
Yes. So I think this is the depiction of the manual procedure. Almost same table we will get there when we are talking about the output of the ANOVA using SPSS. Almost similar kind of table you will get. You will get the sum of squares, you will get the degrees of freedom, you will get the mean square, you will get the F value, and apart from that, you will need to have one more thing, that is the significant, that is the P value, right? So this is we will see when we will move for the output of ANOVA. How to perform one-way ANOVA in SPSS? This is the procedure. So rather than reading, we will see how to perform, right? So I think this is about the one-way ANOVA. If you are having any conceptual problem or confusion, you please ask me, or else we will move for the one-way ANOVA using SPSS. Yes. Do you have any problem? Please say.
No, ma'am.
Okay, fine. So if no issues, no problem. Give me a second. I'll just. So friends, today which sheet you need to use? We need to use the sheet which I have given previously with the name employee data. I hope you are having the sheet.
Yes, ma'am.
Yes, thank you. So okay, give me a second. I'm opening it. Yes, I think it is open in my. I need to share it. Give me a second. I'm sharing my screen. Yes, I shared my SPSS screen. I hope it is visible to everyone.
Yes, ma'am, it is visible.
Yes, ma'am. It
Yes,
is visible.
fine. So I think it is very, very familiar to everyone. Already seen this sheet previously also. There we are having various variables available. Gender, date of birth, education level, or job category, salary, etc. Right? So here I think I'll consider the variable, suppose salary, which we have already considered previously, that is the current salary. But with salary, previously we have taken gender, right? And if you can recall why we have taken gender and which case we have taken gender, can anyone tell me? Gender and salary we have taken in which particular test? Yes? Anyone? Anyone can recall?
Independent.
Very correct. In the case of independent sample status, same sheet we have used, and from this sheet we have taken two variables, gender and the salary. And there the requirement is we need to have at least two groups in case of independent sample status. We need to have only two groups in case of independent sample status, right? So that way, gender and salary combination was good. But here we will take salary. Along with that, we will take job category, right? So I request everyone, if you are having the same data sheet, you will have opened it, go to the variable view. And then when you have clicked on the variable view, come to the job category, and there you can click on the value. That is showing you if there will be any missing value, it was quoted as 0. 1 is for the clerical category, 2 is for the custodial category, and 3 is for the manager category. Is it clear?
Yes, ma'am.
Yes. So that means according to the ANOVA assumptions, we have seen this thing. We are having one categorical variable, that is job category, and in that we are having three different groups or categories, right? Now, second variable which we have taken is the salary or the current salary, right? So we know this thing. This variable will be your continuous scale variable. So variable requirement is okay, right? Clear to everyone? May I proceed?
Yes, ma'am.
So can anyone tell me here how I will formulate my hypothesis for the ANOVA?
that the salary for all the job categories are equal.
Sorry, sir, will you please repeat?
It could be like the salary for all the job categories are equal.
Very correct.
Mean.
Very correct. So we can say that mu1 equals to mu2 equals to mu3. That means salary 1 or salary for the first group and second group and third group, for all the three group it is equal. Or I can say there is no significant difference in the mean salary of employee on the basis of their job category, right?
Yes.
Is it okay?
Yes.
Yes. So when we have formulated the hypothesis, we have identified the variable and their scale. Now we can proceed for the assumption check. So for checking the assumptions, we need to go to the analyze, need to click on the descriptive statistics, and there we will choose which option?
Explore.
Explore, very correct. So explore I am selecting. Here I think we know we are having the current salary variable, which is the continuous variable, or we can take this variable as a dependent variable. So you need to shift this variable into the dependent list box. Fine. Further, you need to select your job category, which is named as employment category, that you can select and shift it into the factor list box. I hope the shifting is done.
Yes, ma'am.
Further, we will click on the statistics, but I think we will go with the by default option. So you need to press on continue. Click on the plots button. There, I am deselecting stem and leaf and selecting the histogram, then selecting the normality plot with tests. Fine.
Yes, ma'am.
Then click on the continue, then press on the OK to get the output. So I think this output, yes. It is generated in the output viewer. I hope it is visible to everyone.
Yes, ma'am.
Fine. So we are reading the table number 1, which is the case processing summary, right? There you can see we are having the employment category, clerical, custodial and manager, and in that we can find we are having total 363 employees in the first category, 27 in the second, 84 in the third, that is manager. So this is the number given. No missing value in any of the groups. So the total is this. Coming down, talking about the descriptives, you can see for the current salary in the three different groups, clerical, custodial and manager, this descriptives is listed. Fine. So you can find that the mean current salary for the clerical staff is 27,838. For the custodial, it is 30,938. And for the manager, it is 63,977. Fine. You can compare the mean with the median. If you compare the mean and median for the clerical staff category, you can find that there is a good amount of difference. Similarly, for the custodial, if you are comparing the mean salary and the median salary, you can find the difference is very small, right? Then in the manager category, the mean and median, if you will see, so the difference is again high, right? So that way, somewhere we can say this thing, that if I talk about the normality of the current salary or the different categories, so might be possible that there is some problem in the normality, right? Coming down, looking at the skewness in the kurtosis figures, you can see the skewness and kurtosis for the current salary for the clerical staff. You can see that it is very close to 2 and kurtosis is beyond the range. And what was the range of the kurtosis which I told you people?
-3 to +3.
-3 to +3. Very correct. Thank you, ma'am. So this range is means whatever the range I have told you, the threshold range, this particular value is exceeding that, right? So that means might be possible there is some problem with the normality of the current salary for the clerical category. Coming down, looking at the skewness and the kurtosis of the custodial, which is this kurtosis is again is exceeding, but maybe it is little closer to 3, and skewness is in the range. Coming for the manager, we can find both are in the range. but still we cannot comment properly looking at these figures. We can see all these using the test of normality, that is the Shapiro-Wilks test. There you can find all the significant values for all the three categories. Clerical, custodial, and manager, you can find these all are less than 0.05. So what the conclusion we will draw from here? Anyone?
Reject null hypothesis.
Sorry?
Reject null
We will
hypothesis.
reject null hypothesis. Very good. So conclusion will be what, ma'am? Decision is we are rejecting the null hypothesis. It's correct. What will be the conclusion?
There's a significant difference. There is a significant difference in the salaries of, and it depends upon the job category.
No. I think, sir, you need to understand this thing. We are using this Shapiro-Wilks test for ascertaining the normality here. We have not reached on the ANOVA till now.
Yeah. So, sorry, that means it's not normal.
Not
The variable
normal.
is not normal.
Very correct. Very correct. I think it was Vivek, sir.
Yes.
Yeah, very correct. So we decision is we are rejecting the null hypothesis, and conclusion is we are concluding that all the three means our salary for all the three categories is not normally distributed. For clerical also, for custodial also, and for manager category also. Is it clear to everyone?
Okay, ma'am. Clear.
Okay, if I will look at my graph number 1 for the clerical staff, can anyone tell me or comment that what will be the skewness looking at the graph?
Positively skewed,
It is
madam.
positively skewed. Very correct. Going down, looking at the custodial staff, I think it is not narrating properly any status, right? So I think we are skipping this. Coming down, looking at the manager category. So what I can interpret from this graph?
This is also positively
It is
skewed.
also positively skewed. Very correct. Same thing you can see. This is the positively skewed graph. This is no proper interpretation you can draw. This is again the positively skewed graph, right? Coming down, looking at your box plots. So you can find for all the three categories, clerical, custodial, and manager, we are having 3 box plots for the salary, right? So in all the 3 box plots, we can find that asterisks are present there, right? That means if there is some problem with the outliers also, these or the outliers are present in all the 3 categories. So means there are certain of the employees in all the 3 categories who are drawing more, because you can find all the asterisks are coming at the upper whisker side. That means you can see here the scale, the y-axis. That means in all the categories, there are few of the employees existing who are drawing more in their particular category. So that means that might be possible that is why these are impacting, because if salary will be higher of 1 or 2 employees, or maybe more than 1 or 2 employees, here if you can see firstly the number of clerical staff, I think it was 300 something, 363 or something. So in that, if some of the employees are drawing more salary, so that way it will increase the mean value. Fine, because it is going to the upper side. So that way, if the outliers are present, they are definitely impacting your mean value. So that will be the conclusion from the box plot. Is it okay and clear to everyone?
Yes.
Clear,
Fine.
ma'am.
Fine. So I think still after the looking at all the assumptions, and instead of we can say this thing, still the variables are or the variable salary is deviating, or what I can say, not following all the assumptions, right? Still I'm telling you firstly how to perform ANOVA using the data, right? So for performing the ANOVA, you need to go to the analyze, go to the compare means, and then select one-way ANOVA. So you can note it down or take a snap of this, go to analyze, compare means, and one-way ANOVA. I hope you found it.
Yes, ma'am.
Fine. Okay. Fine. So I think you need to click on this one-way ANOVA. Once you will click on this, you will be on the this dialog box of the one-way ANOVA like this. You need to shift your necessary variables in the respective boxes. So I think current salary is the most appropriate variable here that I'm selecting and shifting in the dependent list box. Fine. May I proceed?
Yes, ma'am.
Yes, ma'am.
Then select your employment category and shift it into the factor box. So those who are not performing due to any of the reasons, so I'm expecting them to note down the font. I will be a little slower. If not, you can take the pic also of the screen so that you can you would be in a position to understand what we have shifted where. May I proceed further?
Yes, ma'am.
Okay, so contrast I'm not using right now, that we will see later on. Post hoc also I'm not looking right now. Yeah, so post hoc also I am not touching right now. We will go or see this thing later on. I'll click on the options button directly. There you need to select descriptives. You need to select homogeneity of variance test, and that is all. No, there is no use of wells right now. That is all. You need to select only two things: descriptive and the homogeneity of variance test. It is fine. Is it fine, everyone?
Ma'am, repeat.
Okay,
Sorry.
from where? Ma'am, from where I need to repeat?
From analyze, compare me.
Just a minute.
Next one-way ANOVA.
Analyze, yes, compare means one-way ANOVA. Fine. Box is coming
Yes,
like
ma'am.
this.
Yes, ma'am.
Select current salary in
Yes,
the
ma'am.
dependent list box.
Factor
Employment
job.
category in the
Yeah.
factor box.
Factor.
So here it is okay.
Okay, ma'am. Yes.
Contrast and post hoc. Post hoc means this will tell you equal variance is assumed and equal variance is not assumed. So here we are not knowing whether the variance is equal or not. So that is why we are not going for the post hoc right now. So I am not selecting anything here. Directly I ask you to come to the options button. Fine.
Okay, ma'am. Okay, ma'am.
Here select descriptive and select homogeneity of variance test. Is it okay?
Yes, ma'am.
Now click on the continue. If it is okay, I think we are all set to get the output. So you can click on the OK button. So please give me permission. May I click on OK? Is it fine, everyone?
Yes, ma'am.
Yes, ma'am.
So you can see in a one click we have got the output. Output says first table is for the descriptives. There you can find clerical staff is 363 in number, custodial 27, manager is 85, 84, total are 474 employees, right? Mean salaries are listed here. Standard deviation of the salaries is listed here. A standard error of mean for the salary for all the variables is listed here. Then the 95% confidence interval for mean is listed in the next two columns. Then the minimum salary and the maximum salary for all the three categories in the listed in the last two columns. Coming to the test of homogeneity of variances, right? So we can consider the test of homogeneity of variances using usually the mean, as we can know this thing that that ANOVA is a parametric test, right? So generally we need to consider mean, but I think we have also seen that the output was the assumptions were violated by your data. So in that case, we can report the this test of homogeneity of variances using median also, right? But in both the cases, you can find that the significant value is coming less than 0.05. So when it is less than 0.05, what decision we will take?
Reject null hypothesis.
We will reject null hypothesis. Very correct. If we are rejecting the null hypothesis, conclusion will be what? I hope you can recall. I have shown you this thing in the slide. Hypothesis for the Levens test we have seen there. all the living statistics are listed, degrees of freedom are listed, and these are the significant values.
Significance means are equal, ma'am.
Sorry?
Significance means equal.
Ma'am, this is for the variance. The name
Okay.
of the table you can also see. The title is Test of Homogeneity of Variances. So, if you can recall,
Variances are of the groups are not equal.
this
Variances
is the
of the
conclusion. This is the
ma'am, the
conclusion.
hypothesis for yes, ma'am, this particular test.
Okay, so null hypothesis for the homogeneity of variances test was that the variance is equal for all
Equal.
the groups, right?
Yes, ma'am.
Because generally
Norms
we are
rejected.
writing there is no significant difference in the variance. So no means
Yes.
all the variances are equal. This was
Equal.
our null hypothesis. And
Yes.
according to the yes, and according to the results, we are not accepting the null hypothesis. So we are concluding that variance is not equal,
Yes, ma'am.
right?
Yes, correct.
Fine. Now, coming down, looking at the ANOVA table. ANOVA table, you can see the same table I have shown you when I was talking about the manual procedure. Same table we were doing manual procedure also, or we need to make that same table, right? There you can find sum of squares are listed, degrees of freedom, mean square, F value, and significant value. If you have performed these things manually, you know this thing. Sum of square, whatever value is written, that will be divided by the degrees of freedom to give you the mean square. So this divided by the degrees of freedom will give you mean square. Similarly for the next category also. Then you can see this is the F value. So this will come as the first, that is between groups mean square divided by within groups mean square. This will be, or this ratio will give you the F value. And then we are getting the P value. So this P value is less than 0.05. So if it is less than 0.05, so I think now everyone is used to understand this thing, that the when the P value is less than your level of significance, in that case we are going to reject the null hypothesis, right?
Yes, ma'am.
Yes. So what we are concluding? We are concluding that there is a significant difference in the mean salaries of the employees on the basis of their job category, right? Is it okay?
Okay, ma'am.
So when you're concluding, means first thing is very important to understand here is that when to go for the post hoc test, because now we will proceed for the multiple comparison of post hoc test. So the situation you need to understand that when to apply post hoc test or the multiple comparison, this test will be applied only when you are accepting the alternative hypothesis of the ANOVA test, because alternative hypothesis is stating there is a significant difference, right? That means this hypothesis is saying that a significant difference is existing, but in which pair of group that particular difference is existing, that we are not knowing. So in that case, you need to understand that only when you are rejecting the null hypothesis, in that case, you need to go for the multiple comparisons or post hoc test. But if suppose your significant value is greater than your level of significance, that means you are going to accept the null hypothesis and you are concluding that there is no significant difference. So when difference is not existing, in that is why you need to compare the groups. Is it clear to everyone?
Yes, ma'am.
Fine. So according to our output, this implies us that we should go for the multiple comparison. So we will move for the multiple comparison now. Now, how to do the multiple comparison? For that, again, you need to go to the analyze, compare means, and the one way. Fine. I hope everyone has located. Is it fine? May I click on this?
Yes, ma'am.
Fine. Now you can see everything is set. You do not need to transfer your variables. Rather, you need to click on the post hoc button. So click on that. Once you will click, you will be able to see one more dialog box like this. I hope everyone has reached to this particular dialog box.
Yes, ma'am.
Now you can see there are two groups. One group is for the equal variances assumed. Second group is for the equal variances not assumed. So can anyone tell me in which group we need to go?
Equal variance.
Why? Why should we need to go for equal variance? Can anyone tell me?
It is an F test because we assume that variances are equal for an F test.
Okay. Okay. Any other logic? Any other logic, friends?
Don't know, ma'am.
Don't know. Okay, no issues. So why I have asked this question? So I just a minute. I need to go back. I'm closing all this. Here you need to see the test of homogeneity of variances. What inferences we have drawn? What interpretation we have drawn from here? Anyone? I think I just discussed the interpretation part of this. Can anyone tell me what interpretations we have drawn? Yes. Why there is so much silence?
Ma'am, there is absence of homogeneity in variances.
Sorry.
There are absence of homogeneity of variances.
So I think I said this thing, you need to look at the significant value. If we are looking at the significant value, what we are what decision we are taking, we are rejecting the null hypothesis. If we are rejecting the null hypothesis, what will be the conclusion?
There are absence of homogeneity of variances.
Homogeneity of variances is not there,
Yes, ma'am, absence.
right? Equal variances not assumed will be the case. I
Yes,
hope
ma'am.
it is clear.
Yes, ma'am.
So you need to see this thing whether the variance is equal or not that you are getting in this particular table. This table says that null hypothesis of homogeneity of variances, that is Leven's test, is not accepted here. So we will conclude that equal variances is not there in the variable, right? So you can go to the one-way ANOVA, and in the post-hoc, it is now very clear we will not go in the equal variances assumed, rather than we are going in the equal variances not assumed. Is it clear to everyone?
Yes, ma'am.
So you need to select here the appropriate test. The most used and the famous test in this particular category is the Dunnett T3. So without a doubt, you need to select the second checkbox. And if suppose equal variances assumed will be the situation, so this 2K test you can use. The second number, second row, second number, second column, second row. You can see this 2K is visible to everyone, right?
Yes, ma'am.
So this will be the case when the variance is equal, but here the variance was not equal, so we are going with the Dunnett T3. Significant level is 5%. You can press on the continue, click on the OK button, and in the output this time you will get one extra table named as multiple comparisons post-hoc test. Is it okay?
Yes, ma'am.
Right. So now there you need to see that all the three categories are listed at the very or extreme left. Then the comparison was there in the next column. So clerical is compared with the custodial. Clerical is compared with the manager. Then similarly, custodial is compared with the remaining two, and manager is compared with the remaining two. So that way, it is showing the comparison of all the possibility. But I think you can see from this particular table only that clerical and custodial is compared here and also in the next. So two comparisons were made because this is a way of the output generation. So it is not like we are reading the complete table. Only 3 pairs are possible when we are taking the 3 categories. Clerical and means what were the combination? Clerical and custodial, clerical and manager, and custodial and manager. I think this is suffice for us. And you can see there will not be changes also. So first, when I'm comparing the clerical category with the custodian, you can see the significant value which is less than 0.05. So what this says that there is a significant difference in the mean salaries of clerical and custodial staff. Is it clear?
Yes, ma'am.
Secondly, when we are comparing clerical and manager category, significant value is also coming 0.000, which is less than 0.05. So again, we will draw a conclusion that there is a significant difference in the mean salaries of clerical and manager staff. Is it clear?
Yes, ma'am.
Yes, ma'am.
Now you can see custodial and clerical we have already compared. This was the A equals to B or B equals to A type of case, right? So you can see there is no difference in the significant value, right? So rather than that, we are comparing the last category, that is custodial and manager, which is again less than 0.05. So we can say this thing that there is a significant difference in the mean salaries of custodial and manager staff or manager category. Is it okay? Is it fine, friends?
Yes, ma'am.
I hope no doubts. I think I'm not getting so many voices. Is it fine?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, fine. So now the next thing is when we are looking at all the 3 comparisons, and in all the 3 comparisons, we are concluding this thing that the significant difference is existing in all the possible pairs, right? So we can see one more thing when we are coming to the mean differences, that we can say this difference is coming negative. Clerical staff mean salary and custodial staff mean salary. So the difference of these two, which is a negative. So that means that custodial staff is drawing more mean salary in comparison to the clerical staff. Similarly, clerical staff mean salary minus manager staff mean salary. So it is coming again negative. That means manager category people or employees are getting more salary in comparison to the clerical staff. Last, custodial and manager, which is again negative. So we can conclude that the manager employees or manager category employees are drawing more mean salary in comparison to the custodial employees or custodial category employees. Is it clear to everyone?
Yes, ma'am.
Yes,
Fine.
ma'am.
Fine. So now we will see the last option of the ANOVA, that is the contrast. I hope I can start explaining this. Do you people need to write something, or I need to repeat something for you?
No, ma'am, continue.
Fine. Now the last option is the button which I need to explain you is the button of what do you need to do this time? We need to see the contrast button. So I hope everyone has reached on this particular box and selected the contrast button. Open, everyone.
Yes, ma'am.
Here I will come to the coefficients section. Purpose here is what? In the coefficients table or this particular this particular section is helping you out to perform t-test also. Means it is not like one options I have already shown you how you can perform independent samples t-test. Second facility we are getting here to perform t-test in the case of this particular section. But we know the limitation of the t-test. Can anyone repeat the limitation of the t-test, independent samples t-test?
Test value average 100.
No, I'm asking what is the limitation of independent samples t-test? Whatever I'm telling you people, I hope it is clear to you or not. Or you people are not making your notes.
Yes, ma'am.
Making?
I'm making.
Okay. So I think I'm expecting the answer that what is the limitation of independent sample t-test?
Basically, there is a assumptions. Then, can you?
I think how many members are there in a team? In a meeting, there are 41 of you. Okay. I think the number is same till the date. So I hope you people have studied this. I have already told this thing. Yes. No answers? Do I need to tell you this?
Ma'am, I think t-test is a small sample test and this one is a large sample test.
I think this thing.
Only
I-
two variables you can compare in t-test?
Sorry, Kritika ma'am?
Yeah, only two variables.
Yes. Not two variables, only two groups.
Sorry,
Variable
two
will
groups.
be two
not
only.
two
That I have
groups.
already told. Very correct. May I know the name? It was Ritika ma'am?
Sangeeta.
Sangeeta ma'am. Very correct, Sangeeta ma'am. So the limitation of independent sample status is that in case of independent sample status, we can compare only two groups or categories, right? So we know in this particular example, we are having more than two categories, right?
Yes,
Three.
three, ma'am.
Yeah. Can anyone name them?
Clerical,
Yes.
managerial,
Very good.
Custody.
Custodial. Very correct.
custodial.
Please be confident. Whatever you are speaking, say with the confidence. Very correct. So we are having the three categories or three groups, that is clerical, custodial, and manager, right? And as we know, if we want to perform t-test, we can compare only two categories. So that means if you want to perform t-test here, you need to decide upon which two categories you want to compare. So I think I want answers from you. Which two categories we want to consider here? Anyone? Which two categories we need to compare?
Clerical and
Clerical and
custodial, ma'am.
custodial. Fine. So what you need to do? Sorry. Any other suggestions? May I proceed?
Yes, ma'am.
Yeah. So as I think one of you said, we need to compare clerical and custodial, right? So what you need to do, come to the coefficients box and write one number here. Suppose I am writing only one, right? Click on the add button. We know this thing that I have shown you in the values. There were three categories: clerical, custodial, and manager, right? So we want to compare first two categories. So what I did, I have given a number for the category 1. Coming to the second, whatever number you have given for the category 1, now you need to reverse the sign. 1 was positive, so we are taking -1 here and click on the add button. And third category we do not want to consider, so give this particular category as a 0. It is not like you need to always use one only. You can use any of the number, but you need to make sure that the coefficient total should always be 0. Then how this will come? Whatever number you are taking for the first category or whatever category you are comparing, same number you need to take with the minus sign or the next category. Is it clear?
Yes, ma'am.
Press on the continue. Right? Now press on. I think if you want to do the changes here, but why I am doing, so that we will not get more outputs. So I think I'm eliminating most of the things here. So we will get the less number of tables only. So I'm pressing on OK. And you would be able to see you are getting ANOVA table, as this was the one-way ANOVA dialog box, so by default it will give you the ANOVA that we are getting here. And then in the contrast, it is showing you that what two things we are comparing: clerical 1, custodial -1, manager is 0. Is it clear?
Yes, ma'am.
Coming down, see the contrast test. This there you can find the T value you are getting and the degrees of freedom you are getting here along with the significant value. Assume equal variances or not. So we are considering variance is not equal, as we got this thing in the output of the ANOVA previously. If you can see this table, there we have decided this thing that the variance is not equal. So what you need to do, you need to consider does not assume equal variances. Need to go to the second row, this particular row, and there you can find the P value is -5.452 for the 93.072 degrees of freedom, and the significant value is 0.000, which is less than 0.05, right? Which is less than 0.05, meaning is what? We will not accept the null hypothesis of the t-test. And can anyone tell me what will be the conclusion here? Anyone? Anyone?
There is a significant difference in all three means, ma'am.
In all?
Three means.
No, ma'am. I think we are comparing only clerical and custodial. So why we will say in all three?
Okay.
T can only compare two.
Okay, ma'am.
I think it's the last day of the workshop. I request everyone, please, whatever I taught you, I tried to convey you. If you
There is a
people-
significant difference between the clerical and custodial salaries. Will be the
Very correct.
answer.
You can say there is a significant difference in the mean salaries. Always say mean because we are comparing mean
Yes,
using
mean
NOVA and the T, right? So there is a significant difference in the mean salaries of custodial and clerical staff, right? Then you can see the mean value is, I think we are getting here. Contrast values you are getting here. So that way you can see clerical minus custodial. That means custodial staff is drawing more mean salary in comparison to the clerical staff. Is it okay?
Yes, ma'am.
Okay, so I think this is the end of the day. I will conclude whole 7 days now. So I think please listen patiently and attentively. Maybe this can help you. I'll start with the day 1, where we have seen the basics of SPSS. There I tried to explain you the basic research components for a particular study. I talked about what are the components and what you need to try to write down those components. Although the session was very short, as I need to discuss the SPSS. Then I have shown you SPSS. I talked about what we can do in SPSS. We have seen how to create variables, what are the rules of that. We have seen all the parameters. I need to show you this topic. We need to see all the parameters here of defining a variable. I have explained you each and every parameter here, right? And we have seen this thing once we are defining a variable that is becoming the column heading in the data, right? Then we have seen how to import data. I've shown you using the file menu. You can go to the open and then data, or you can click on the import data, and according to the file extension, you can select your file, or you can click on this open data dialog box, right? So these were the ways we have seen to import the data in SPSS. So I think this was the day 1. Second day, I talked about the reliability concept and the normality concept. So in the reliability, I explained you that it is nothing but it is a measure of consistency, whether your scale means your questionnaire or your instrument is producing same result again and again when you are conducting it on a different samples of a same population. This is the reliability. We have seen various methods and we discussed the internal consistency method, and we have seen that how we can get Cronbach alpha in the SPSS. So you need to go to the analyze, and then in the scale and reliability analysis, you can find it, right? This is the reliability concept we discussed. We have also seen that how we can improve the convex alpha using the atom total correlation. This is what I discussed with all of you. Same day I discussed the normality also. We have seen the concept of normality. We have seen what are the various methods. Using them, you can see the normality of a variable. So I discussed two methods, numerical methods, and I have discussed the next method, that is the graphical method. In numerical method, I explained you skewness and kurtosis, then Shapirovich's test, and then Kolmogorov-Smirnov test. These were the three numerical methods. Using that, we can check the normality or ascertain the normality. Then we have seen the graphical methods. There I talked about box plot, histogram, and QQ plot. So these all were used to check the normality. This was the day 2. Further, I talked about the chi-square test, which was the non-parametric test. Then we have seen two types of chi-square goodness of it. It will be for the single categorical variable, and there we are comparing the categories of a single categorical variable, and we are comparing the frequencies observed and expected. Secondly, we have seen the chi-square test, that is a test of association or independence of attributes. There I told you there will be two categorical variables, and that we are generally writing in the contingency table. I explained you the hypothesis also, that how to formulate the hypothesis. Then we have seen how to perform both the tests using the SPSS. Next day, I think I discussed only the one sample t-test. We have seen what is the t-test. Then what is the difference in P and Z we have seen. Then we have seen how to perform t-test. Assumptions also we have seen. Then we have seen checking of the assumptions using SPSS. And lastly, we have seen how to perform one sample t-test using the SPSS. Next day, I talked about independent samples t-test and the paired samples t-test. There we have seen that what is the independent groups, what is the dependent groups. We have seen the variable requirements, and we have seen assumptions for both the tests, checking of those assumptions, and how to perform them using SPSS. This was the day 4. Next day, I talked about, till now,
Regression and correlation, ma'am.
Next day was the regression and
Regression and correlation.
Correlation and regression. Yes.
Yeah. So next day we have discussed regression and correlation. There I told you correlation can help you out to find the strength of the relationship, that is the degree of the relationship, and also the direction of the relationship. We have seen there are various types of correlation tests available according to the types of variable. I discussed the Pearson's correlation only, which is used for the continuous variable or numeric variable, right? We have seen its interpretation part, and then further we have talked about the regression. I told you correlation cannot study the cause and effect relationship. For the purpose, we are using the regression. Regression is used for the modeling also, and using that we can do the forecasting also. So the dependent and independent variable we have discussed there. We have seen the normal or mathematical equation and the statistical equation for the regression. And then we have seen assumptions of regression. We have seen further how we can check assumptions, and then how to perform regression and its interpretation. I think this we have discussed. And lastly, today I discussed about the ANOVA. And in ANOVA, I have already discussed one-way ANOVA. We have seen the difference in the independent samples t-test and in one-way ANOVA. We have seen that when we need to go for one-way ANOVA, we have seen its various assumptions, variable requirements, and we need to check how to check assumptions of one-way ANOVA using SPSS. And lastly, how to perform one-way ANOVA. And the important thing was that when your one-way ANOVA hypothesis, that is null hypothesis, is rejected, in that case, how you can perform post-hoc test or the multiple comparison you can do, that we have seen for the equal variances and unequal variances. So this is about all the 7 days crux, which I have just tried to narrate you. So I think it is all from my side. I wish you happy learning, and maybe you will now excel in your research. This is all the best wishes from my side. Now the platform is open for the question and answers. Yes, any questions?
Excuse me, ma'am.
Yes, sir.
Ma'am, today I have tried to these analysis in Excel format, in Excel software.
Okay.
I cannot perform not any. I cannot confirm. Sorry, I cannot perform any test such types of this in Excel.
Sir, Excel data format is different. Here in the data, whatever data format we are using, it is different. Are you using my files there or using your own data?
Okay, madam.
No, I'm asking you, are you using the data sheet which I provided to you or you're using your own data sheets?
नहीं मैम, मैंने ऐड ऑन डाटा ऐड ऑन शीट करके और उसके अंदर फिर एक हमारा ऐड टूल के अंदर ही या स्टैटिस्टिकल टूल या मेगा स्टैटिस के अंदर नाम से कोई टूल है, वो ऐड करने की कोशिश कर रहा था, वो हुई नहीं।
Okay, so in that case, sir, you need to firstly add the data analysis tool pack in your Excel. Only then you can perform a statistical test, or else you can only see mean, median, mode, etc. That is descriptive statistics, normally using the functions or formulas.
Yes, ma'am. ये तो normally functions हैं. These functions show on formulas and statistical formulas and so on. This show on
Yes.
that.
Yes, this is what I am saying. For that, you need to use that particular data analysis tool pack, sir.
Okay, ma'am.
Yes. Yeah. Anything else? Great. No questions. Okay. So can we? Can I ask you to switch on your cameras?
Hello.
Yes, ma'am. I think I can hear you.
Thank you so much, ma'am.
My pleasure.
I learned a lot of things. Before starting, I have a lot of confusion and doubts, but now somehow I'm very clear what is ANOVA, what is independent t-test, what is regression, what is dependent variable, independent variable. Thank you so much, ma'am.
I think it's a compliment for me if you have got clarity for this, ma'am. Thank you so much. I think you have drawn most of the things from the workshop. Thank you.
Yes, ma'am.
Thank
you so much.
Thank you, ma'am. Yes, and anything else?
Ma'am, this was an introductory module. Will you be introducing intermediate and advanced as well in the future?
Definitely, ma'am. I'll try. As I said previously, also the thing is that what happens actually if I want to, I have to deliver something. It is not like for me only. I think
Yes,
it happens with all of us. So we need to have everything ready with us.
Yes.
So I need to work on my PPT part. I need to work on my
Of
data
course,
sheet part also. So probably it will take some time, but definitely I'll try.
Yes, ma'am. Ready to join that also.
Definitely.
We are all very
Yeah.
eager and ready to join that.
Thank you so much, ma'am. Probably in a month or something, we will
Sure,
launch
ma'am, of
something.
course. And we'll wait, ma'am. It'll be worth the wait. Okay.
Definitely, we will do that, ma'am. Okay. Anything else? Nothing. So,
Nothing,
okay,
ma'am.
it's time for a photograph. If you can switch on your cameras. Yeah, beautiful faces. I can see now. I think when you deliver in online mode, it is quite difficult. We are not looking at anyone, and we are feeling like we are only interacting with the screen. Thank you so much, everyone, for switching on your cameras.
Excuse me, ma'am.
Kind of booster for me. Yes, ma'am. Yes, sir.
Thank you, ma'am.
Ma'am, after the meeting, we need if we need fulfill the feedback form or not.
I think, sir, usually RFI is not doing such kind of thing. But if you want to post your feedback, you can post on the WhatsApp group. I am there, and I'll accept your feedback if you are posting anything on WhatsApp.
Okay, madam.
So I think this is all, everyone. Happy learning to all of you. I wish you a great research career ahead. And I hope whatever you have learned, you will now apply in your research papers and your research studies, right?
Thank you, madam.
Thank you, ma'am.
Thank you
Thank
so
you,
much.
ma'am.
Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.
And I think I forgot to thank you to RFI. I must say, RFI team, thank you so much, especially Ajay Jain sir and Yogaraj sir. I think I forgot every time to say thanks to Yogaraj sir. He is the one. He is always helping us out in joining the WhatsApp group and everything. Thank you so much, Yogaraj sir. Over to you. We are done with the session. Thank you.
Thank you, ma'am.
Thank you, everyone.